Hello students, today we are going to discuss about two problems in periodicity of a continuous time signal. So we are going to determine whether these two signals are periodic or not. Okay. So in the last lecture we have discussed that how to determine a signal whether it is a periodic or aperiodic. So when a signal repeats again and again after a particular time period, then it is said to be a periodic signal. Okay. And generally whenever we take a continuous time signal, how we say that it is a continuous time signal? Whenever it is denoted by small t. Okay. A discrete time signal we use to represent it as n. Okay. So here we are considering two examples of a continuous time signal. So we have small t. Okay. How we can define that it is a periodic? Whenever you have x of t, right? Whenever you have x of t is equal to x of t plus capital T, then it is said to be a periodic signal. And if this condition is not satisfied, then it is said to be a aperiodic signal. Okay. And in general, whenever we see a signal, okay, suppose we have a diagram representation, easily we can say, okay, whether after a particular time period the signal has been repeated or not. If it is not repeated, then it is said to be a aperiodic signal. But when they give as a mathematical equation, okay, first we have to determine the capital T value. Okay. And in general, we know that, okay, in general, in continuous time signal, if we take continuous time signal, definitely a sinusoidal signal, right, or a cosinusoidal signal is said to be a periodic signal. Okay. So no need to find out anything. If they ask in 2 marks, you can directly say, since x of t is a sinusoidal signal, it is said to be a periodic signal. Okay. And since your x of t is said to be a cosinusoidal signal, it is said to be a periodic signal. Okay. So we know that definitely it is a periodic signal. Why? Because it is a sinusoidal signal and cosinusoidal signal. And how to determine then the fundamental time period? Okay. So in the problem they will ask. Okay. So they will ask to determine whether a signal is periodic or not, and if it is periodic, okay, if it is periodic, we have to find out the fundamental time period. Okay. So for first example is equal to sin 45. Okay. And as I said, generally the sinusoidal signal is said to be a periodic signal. Why? Because in general, what is the curve? So we will have like this waveform. So definitely it is said to be a periodic signal. Okay. So how to find out? How to find out this signal is said to be periodic or not? So what we have to find out? First, fundamental time period. Okay. So the fundamental time period, what is the formula? Capital T is equal to 2 pi by omega. In this signal, so when you observe this signal, generally the sinusoidal signal, how it will be represented? A sin, simple sinusoidal signal will be represented by A sin omega t. Okay. So when we observe this signal, okay, A is nothing but 1. Okay. Omega is nothing but T's coefficient. Here, what is the T's coefficient? It is 45. Okay. So it is 45. T value is 45. So sorry, omega value is 45. So we know that omega value is 45. Okay, T's coefficient is nothing but omega. So what about capital T? 2 pi by 45. Pi get cancelled. Is 1 by T. Okay, T is measured in unit of seconds. So you can just write your statement that. Why? Because sinusoidal signal always it is said to be a periodic signal. So we can write your statement that x of t is periodic signal with fundamental time period capital T is equal to 1 by 20 seconds. That's all. Okay. So now let me move on to your second problem. So your second problem is x of t is equal to 2 cos p by t plus pi by 2. And in general, again, it is a continuous time signal and it is a co-sinusoidal signal. Co-sinusoidal signal, how we will represent? Sinusoidal signal always starts from zero amplitude. Co-sinusoidal signal will start from maximum amplitude. So from here you have to draw your curve. Okay, so like this it will repeat in the left hand side also. Okay, so this is your general format of your co-sinusoidal signal. Okay, so co-sinusoidal signal also definitely will is a periodic signal. Okay, so by seeing the problem itself we can say that it is a periodic signal. Okay, then how to find out the fundamental time period? Again we have to compare with the general notation. Okay, what is the general notation? So as I said, a cos omega t, this is your general notation. But whenever there is a phase shift, okay, sometimes there will be a phase shift also. Okay, like this you can represent. Okay, so phase shift also will be there. No need to consider about phase shift and all here. Okay, no need to consider here. What you require? Okay, what you require? The fundamental time period. So generally they will ask you to find whether the signal is periodic or not, as well as they will ask you to find out the fundamental time period. So what is the formula? 2 pi by omega. So I don't have any value of phase shift. Okay, so no need to substitute this value. So this value is not required at all. So what do you require? Only the omega value. What is the omega value? 3 pi. So substitute that. 2 pi by 3 pi. Pi pi get cancelled. So you will get 2 by 3 seconds. Okay. So if it is a one signal, there is no issues in continuous time signal. If it is a sinusoidal or co-sinusoidal, you can generally write your statement that x of t is periodic with fundamental time period capital T is equal to, here it is 2 by 3 seconds. Okay. Thank you. Thank you students. Thanks for watching.